My name is Lucas, and since getting a 1570 on my SAT, I've helped over 1,000 students get their dream SAT score. In this video, I'm going to do something that no YouTuber for the SAT has ever done before. I'm going to show you a problem that I know with 100% certainty is going to be on your next SAT. After I show you, we'll go over how to solve it. All right, sound good? Okay, let's get going. So, what is the question that I can guarantee with 100% certainty is going to be on your SAT? The answer is a units question. Okay, I know that's probably not what you were looking for. You probably wanted like an actual leak about a question that's going to be on the SAT. But before you click away, I want to tell you that this is just as good as a real leak, because every single SAT, there are 5 to 7 units questions. And the cool part is that these are literal copy and pasted versions of the same question, just with different wording. So if you can learn how to approach these problems, you're just going to throw in different numbers and different units that they use, but it'll be the exact same problem. So it sounds obvious, but especially in harder problems like the one we're going to look at the end of this video, a lot of students don't recognize problems to be unit conversions, when in reality, you can just use unit conversions and they become so much easier than trying to use a different method. And I can guarantee you they will show up 100% of the time. So if you're a beginner with units, this will teach you how to do even the most basic problems. But if you're already advanced and you've already mastered units, or at least you think you've mastered them, this will show you more advanced techniques and situations that you might have not known you can actually use units in. So no matter what skill level you are, this is going to help you on your next SAT. All right, first let's look at the level 1 question. Okay, so in this first problem, it says a printer produces posters at a constant rate of 42 posters per minute. At what rate in posters per hour does the printer produce the posters? Okay, great. So this is our rate right here, 42 posters per minute. So let's go ahead and put that as a rate. So we're going to have 42 P per 1 M, where basically this is saying we'll have 42 posters P produced per 1 minute M. Now we're trying to get it to posters per hour. So basically what we're doing is this is our starting point in 42 posters per minute. And where we're trying to end up is in some amount of posters, but now per 1 hour instead of 1 minute. All right, so how do we get here? Well, the most important thing is that we have to remember to maintain the value of this, because it's still going to be the same rate value-wise. The printer is not going to start creating the posters quicker or slower, so it needs to be the same value. All we're doing is changing the units. So I want you to think of this 42p not as one distinct thing, but as two separate things where the first part is the number and the second part is the unit. And then same on the bottom where the 1 is a number and the m is a unit associated with the 1. So now, how do we get from here to here? How do we change the units? Well, one thing that you should know is that if you multiply anything by 1, it's still going to equal itself. So if you take 5 and you multiply it by 1, you just get 5. If you get 7 and multiply it by 1, you just get 7. So if we multiply this by something that equals 1 but changes the units, then we'll end up with something that has the same value but with different units. So for example, if we took 60 minutes and we change that to 1 hour, that would be the same thing. 60 minutes equals 1 hour. So what we can do is we can actually put this 1 hour on bottom. So 60 minutes divided by 1 hour is actually altogether equal to 1. And so if we multiply our original value by this, it will actually still equal itself. So let's take this 42p over 1m, and then let's multiply this by 60m over 1h, where this is just 60 minutes over 1 hour. So when we multiply this by 60m over 1h, I want you to treat the number and the unit independently. So in the end, just ignoring the numbers for now, these m's are going to cross out, one on bottom and one on top, and we're going to end up with something where the units are p over h, because on top, all that we have left in terms of units is p, and on the bottom, all that we have left in terms of units is h. So this will give us a rate that's in posters per hour, which is the unit that we want to have for our answer. So now we've made sure that the units cancel out. So the next step is just to multiply the numbers. So that's the process you need to go through, is you deal with the units first, and then you just multiply the numbers, and they'll always work out as long as you dealt with the units correctly. So we're going to do just 42 times 60 over 1 times 1. So 42 times 60 is 2,520, and then 1 times 1 is of course just 1. So anything divided by 1 is just itself. So we can say that our final answer is 2,520 posters per hour, and that is our final answer. Okay, next let's look at the level 2 question. Now for this next problem, it says the International Space Station orbits Earth at an average speed of 4.76 miles per second. What is the space station's average speed in miles per hour? Okay, great. This looks very similar to our last problem, but there's going to be one key distinction that will have us do an extra step in this one, which makes this one a medium question and the first one an easy one. All right, so let's do the same thing and start with the value that we're given and make sure to give it units. So we know that the average speed is 4.76 miles per second. So once again, make sure we just stick this 1 on so that we make sure that we know that there's both a number and a unit for both the top and the bottom. And then once we do this, we know that we need to do the same process where we're going to multiply this by some rate, and then we're going to end up with something that equals, well, we're looking for miles per hour. So we want something miles per 1 hour. Okay, we can see that the m is consistent all the way to the end, so we don't have to mess with this m. It's good where it's at, and we want this to be in our final units. So without thinking about numbers, once again, let's just try to figure out different ratios which altogether equal 1, so that we're not actually changing the value of this rate, we're just changing the units, and which ends up giving us the units of miles per hour instead of miles per second. Okay, well, we can see that we're trying to make the bottom go from seconds to hours in terms of units. So what's the first thing that we can do there? You might not immediately know a conversion that goes straight from seconds to hours, but think about how we could maybe get closer. Like, for instance, how many seconds are in a minute? Well, we know that there are 60 seconds in a minute, so what we can do is actually put a seconds unit on top and a minutes unit on bottom. These s's will cancel out, and then we just want to make sure we throw in the right numbers, so 60 over 1. The problem here that you can see is that also make sure that this m on top is miles, this m on bottom is minutes, so don't get those mixed up. But you can see that we have now miles per minute, but we want to end up in miles per hour. So what we do is we actually do this exact same thing again. So now we have to think how many minutes are in an hour, because we know that we want to multiply by minutes per hour so that these m's cancel out and we're just left in miles per hour. So of course, minutes per hour is of course just 60 over 1 again. And so you can see that both of these rates equal 1 because 60 seconds is 1 minute and 60 minutes is 1 hour. So they both equal 1. We're not changing the value of this rate, but now we went through that same process 2 times because of course 5 times 1 is 5, but also 5 times 1 times 1 is still 5. So you can do this process as many times as you need to get from the unit that you start with to the unit that you're looking for the answer. Okay, awesome. Now we've checked that we end up in miles per hour. So this part of our answer is checked off, and now we can just deal with the numbers. So we can see that we have 4.76 over 1 times 60 over 1 times 60 over 1. So what we're really looking at in terms of the actual number up here is just 4.76 times 60 times 60. And when you plug that into a calculator, it's going to give you D. So D is our final answer for this problem. And you can see that even the medium problems are not too bad. It's usually just going to be 2 or 3 steps instead of 1 simple step. All right, before we go on to the level 3 question, I just want to do a quick disclaimer. I do run a community called SAT Masterclass, and like I said, I've helped over 1,000 students improve their scores. We currently actually have a 1450 or above score guarantee going on, so you can join completely for free using the link satmasterclass.org. So feel free to check it out. You can join completely for free. There's no credit card sign up, anything. You just join with 3 clicks and you're in. Okay, now on to the level 3 question. All right, for this last problem, let's read through it before we try to tackle it straight away. It says, Alan drives an average of 100 miles each week. His car can travel an average of 25 miles per gallon of gasoline. Alan would like to reduce his weekly expenditure on gasoline by $5. Assuming gasoline costs $4 per gallon, which equation can Alan use to determine how many fewer average miles M he should drive each week? Now, it might not look like it, but this is actually just another unit conversion problem. And that's because units are completely subjective. As long as we set 2 different things equal to each other, we can treat it like a unit conversion. So, for instance, let's say that I think that 1 banana is equal to 3 apples. Well, then what we can do is we can say, well, 1b over 3a equals 1, and we could use this to convert between bananas and apples, which is really cool and really helpful because like in this question, as you see, you can use it to translate and convert between units that aren't traditional units like, 60 seconds per 1 minute. That's a more traditional one you might see. But in this one, you can see that we'll actually be able to relate things like gallons and dollars and miles. So that's going to be super helpful. So let me go ahead and clear this up and we'll get started with this problem. So let's just first identify all of the different rates that we have in here. So starting at the beginning, Alan drives an average of 100 miles each week. Now, the word each might make you think that this is a rate, but really we're not looking at something that takes place over many weeks. So if we were to write like 100 miles per 1 week, this would never actually help us convert to anything because this problem is only looking at the scope of like a single week. So we don't need to use it to convert between multiple weeks. So let me go ahead and clear that up again because that's not actually a ratio or a rate that we want to use. But continuing on, it says his car can travel an average of 25 miles per gallon of gasoline. Okay, great. So that's our first rate that we want to use, which is 25. And then I'm going to write out the complete word miles because there's also going to be a variable m, so we don't want to get those mixed up. But our first rate is going to be 25 miles per 1 gallon. Okay, so that is our first rate. And basically what this tells us is that 1 gallon is essentially equal to 25 miles because 1 gallon will cause the car to travel 25 miles. So this altogether essentially equals 1. All right, continuing reading on, it says Alan would like to reduce his weekly expenditure on gasoline by $5. Okay, great. That's not a rate because it's just going to be like $5. It's just one number and one unit. But what that tells us is that we're going to be looking for something in miles, M, that's going to end up in $5, where dollars is the unit. So we can see immediately that A and C are not going to be the answer because we want a certain amount of miles that will result in $5 less being spent per week. So we can see that this 5 is going to be basically our starting value, where 5 is the number and dollar is the unit. So this is going to be the number and this is the unit. So I'll just write that out, unit. And so we can see that this has to equal some amount M, which is a unit in miles, times something to where we change miles to the unit of dollars. Okay, so let's keep going and see if there's any other rates that we get. It says, assuming gasoline costs $4 per gallon, which equation can blah, blah, blah. Okay, so that is our second rate, which is gasoline costs $4 per gallon. So we're going to write $4, where I'll just use the dollar symbol for the unit, and then it's going to be $4 per 1 gallon. Okay, awesome. Now we have the two rates that we need to convert from miles to dollars. So off the bat, how do we get rid of miles? Well, you'll see that between the two, the only one that actually includes miles is 25 miles per 1 gallon. So this is the one that we have to use, but you can see that we can't just directly plug this in as 25m over 1g, because the problem there is that we'll end up with the units miles squared over gallons, because we'll essentially have miles on top twice and then gallons on bottom. So what we want to do is actually flip this fraction. So we want to have 1 gallon over 25 miles. So we can just write 1g over 25 miles. And the reason that we're allowed to do this is because, say for instance that you have 5 over 5. If you flip these 5s, it still equals 5 over 5, and it still equals 1, because if the top and bottom are equal, you can flip them as much as you want because they're equal. So remember, we said that 25 miles is essentially equal to 1 gallon, so we can flip this and it will still altogether equal 1. So that's just all that we're doing here. And then you can see that the miles on top and bottom will cancel out. So you can see now the left side is still in dollars, but the right side is now in gallons instead of miles. So we've used up this first conversion, but now we're in gallons, and we don't want to be in gallons. We want the 5 on the other side over here to be a unit in dollars. So how do we get from gallons to dollars? Well, luckily, we have this second conversion right here, which goes directly between dollars and gallons. So now we just follow the same process, but this one is already in the correct form because you can see we have gallons on top here, and then the rate has gallons on bottom. So if we just plug in the $4 over 1 gallon, these G's will cancel out and we'll have a unit that results in dollars, which is awesome. Now you can see that based on the units, all they really want us to do is simplify these fractions. So we basically have the 1 over 25 and the 4 over 1. So this is just going to simplify to m times 4 over 25 equals 5, because now we can just ignore all the units because we double checked that they work out to just dollars on both sides. And so now we can see that the answer clearly has to be D. 5 equals m times 4 over 25. That's the same as this one, just flip sides. And so that's our final answer for the hard problem. All right, and that's it for this video. If you enjoyed this video, then you'll probably like this one, which is going to tell you how to approach your second math module on the SAT.